Hi all of you, this is Dr. Diaz again. Okay, this is, well, the problems that I was supposed to give you today in our meeting, but unfortunately that meeting didn't work, so I'm trying to do it now. Now look at this one. First thing we're going to see here, common integral. This is actually what we're going to do here is integration by parts. And you remember some of the common integral. The integration of dx is x plus c. 1 over x is natural log of x. The integral of a constant, you take the constant out, you do the integral dx, which is going to be x times k plus c. And this one, 1 over ax plus b, well, the general form will be natural log of ax plus b. And x to the minus 1, the same as this one, is natural log of x. And then we have here, the natural log of e to the u of the u is always going to be e to u plus c. And more general one for any exponential, a to u du is going to be a to u divided by natural log of a. We're going to do this one later, but I think we're going to use here integration by parts. This is actually not, this is not integration by parts, this is integration by substitution. Don't forget that. Okay, we're going to do later on the integration by parts, and I will have another video for that. So, and in general, we have these equations too. If you have integral of cosine of u du, this is always going to be what? Sine of u plus c. That's the thing. When we do integration by substitution, what we're doing is we're changing this unknown, the x, turning into a u, and then solve for a very easy integral, like this one, e to the u, right? A natural log of the integral of what? 1 over u du, it will be then natural log of u plus c, an absolute value, because remember, negative numbers do not have logarithm. Now let's go to this example here. Oh, check the PowerPoint, there's other examples there, but check this one here. 2 to the 2x e to the x squared. So here the goal is taking a u, this is integration by substitution. We're taking a u, so let's say in this case, let u be equal, in this case, x squared. And then du, when you do the du, you will have what? What's the derivative of x squared? It's going to be 2x dx. Why I'm choosing u being equal to x squared and getting this in here? Because now we look here and we have the 2x, here we have the 2x, and we have the dx. So now the whole thing, 2x dx, is represented by du. And e to the x squared is going to be represented by e to the u, right? Because we said that u be equal to x squared, so then e to the u is equal to e to the x squared, and the u is 2x dx, so every element in this integral is represented. So we say, well, this integral, let me do it here again, of, oh, let me erase this for a second, wait, will be 2x e to the x squared dx is now going to be represented by the integral of what? E to the u du, where du is 2x dx, which is these two fellows in the last term, and e to the u is e to the x squared. And this integral is much easier to solve. Look here, the solution is going to be what? E to the u plus c. And since we said that u from the beginning is equal to x squared, then the integral of 2x e to the x squared dx is just what? E to the x squared plus c. And if you're not sure, the only thing you have to do is do the derivative of this fellow, right? Let's do it here for a second. And here we have, what's the derivative of e to the x squared plus c? Well, we know the derivative of c is going to be 0, so it's basically the derivative of e to the x is going to be e to the x squared times the derivative of x squared, which is 2x, and then we have 2x e to the 2x squared. Let's do this one. And here, let's do this. Let u be equal to x cubed plus 5. Why I didn't choose let u be equal to x squared? Because if I do the derivative of x squared, I'm not going to get this x cubed. But if I do the derivative of x cubed, I will get the x squared. What's the derivative of the u? It's going to be derivative with respect of x of what? Of x cubed plus 5, which it will give us what? 2x squared dx. Aha! And look what happened. Well, we have a 2 here. Basically, we have du is equal to 2x squared dx. Look what's happened. X squared dx is here represented, and we already called this one u. We call this one u, right? So now what we have to do here is, well, let's substitute, divide both sides by 2, and then this will be what? Du divided by 2, or 1/2 du is equal to x squared dx, which is actually here. Let me get rid of those. Now looking at this integral, we have that x squared dx is equal to 1/2 du, and this fellow is actually what we call u. So rearranging now this integral is going to be what? Well, this fellow, we call it du. Actually, it's 1/2 du, right? And this fellow here, we just call it u. Yeah, we'll define it here, u. So then we will have what? We put here 1 over u times 1/2 du. The 1/2 we can take it off. Put it out of the integral. I mean, yes, it's not out as a constant. And then we have 1 over u du. And let's divide this because we're going to solve the problem here. And now you see, what's the integral 1 over u du? Exactly, natural log. This is equal to 1/2 natural log absolute value of u plus c, because it doesn't have limit of integration. But because we already start defining that u is equal to x cubed plus 3, then the integral, let's put it here, the integral of x squared divided by x cubed plus 5 dx is equal to 1/2 natural log of x cubed plus 5 plus c. Yeah, that's it. Good. Let's do the next one. You see, this is another alternative, another way to do this problem. Well, actually, it's not another way to do the problem. This is actually more complicated. But we can solve this one in a second. The first thing we say, okay, it's a rational function. How we get rid of this one? Hey, not that difficult. Look at this one. 1 minus x squared. Hey, isn't this the difference of 2 squared? Yeah, it is. It is 1 minus x times 1 plus x. And if we rearrange this integral, we put it like this. 1 plus x divided by 1 minus x, 1 plus x. We can see clearly that 1 plus x and 1 plus x cancel, and we will have just the integral of 1 over 1 minus x dx. And what is the integral of 1 minus x dx? Natural log. So the integral of this thing is going to be natural log 1 minus x plus c.